Really appreciate your patience with that. Technology was not agreeing with me. So, here's a continuation of what we've been working on, Chapter 4. Hey, guys. Hey. Hi. Thanks.
Hi.
Thanks. Glad I got your attention. This is a continuation of the greatest common factor yesterday. Now we're doing the least common multiple. Once again, this is often an issue where you think of the word least and you think of something small. But if you think of the last word, which is multiple, think of something that's big, because when something multiplies, it increases, right? As long as it's by a whole number. Stacey, can you put that away, please? As long as it's by a whole number, right? Yes? Okay, I was looking over there now. This is the biggest, or the smallest linebacker, or the smallest lineman on the Rams. Did I do that connection with you guys yet? Okay. This is the situation where it's the smallest of something big. So it's the smallest lineman on the St. Louis Rams. Okay? It's the least common multiple. Multiple is a key thing that keep in mind that it's going to be a bigger number than a factor. There are 3 different ways we can find the LCM of a number. One of them is prime factorization. One of them is listing multiples. And then there's also the ladder method again. And I'm going to put doesn't work with all. With that one. The ladder method. Position that it should be. Not putting any product in there. Right now?
Well, yeah. Just whip out your iPhone, whatever, look at the camera and go, my hair is on.
Listing multiples. Find the LCM. Yes, find the LCM of 12 and 28 by listing multiples of each. It may be quicker, it is going to be definitely quicker for you guys, to list the bigger one first, because you guys are familiar with multiples, so it'll be quicker. So all I'm going to do is just add 28 by 28 again. So I have 28, 56, 76 plus 8 is 84, 112. Okay, do you see any of those that are a multiple of 12? Okay, so I have 12, 24, 36, 48, 60, 62.
72.
Ooh, yeah, thank you. 72. Come on. 84. So I have 84, 84. It's WashU colors. It's both. I'm using it as WashU colors. LCM of 12 and 28 is 84. It's the least common multiple. Now, it's not the least common like where you have attributes of someone that you don't have much in common. Okay? It's the least as far as the smallest of their common factors. Then we're going to do the prime factorization, where we do the upside-down tree on these two. So we have 63. Okay, we want to try to use composite numbers, but 63 isn't have a whole bunch. 7 and 9, 3 and 3. Oh, and as soon as we're done with this, I have the first 560 primes for you guys. So then we have 105. I'm going to choose composite numbers. 5. That's not a composite number, but okay. You can do And that's not much we can do with that, is it? 5, 3, and 7. Write the prime factorizations with exponents. Now, this one here, the more comfortable I got with it, the more I realized that on the pre-algebra version of this test, a lot of people missed this because they did not like this one. I didn't like it at first either, but then I realized that it makes the most sense when you have exponents in there. So it says write the prime factorizations with exponents. So I'm going to reset these up. So I have 63 was 7 times 3 times 3. 105 was 5. I'm going to put them in order. 3, 5, 7. Thank you. 3, 5, 7. You're going to multiply the largest powers of each base. So I'm going to write that as exponential form, which is the same as 3 squared times 7 to the 1. 3 to the first times 5 to the first times 7 to the first. Now, which of those has the largest power of each base? Largest power of each base. So we're going to look at this. We have 3 squared. Is there anything bigger than 5 to the first? Nope, the same base. Base. Remember the base with exponents? Base, power. No, there's nothing bigger than 5 to the first. And then we're just going to take this 7 to the first because there's the same power there. So now we go multiply the largest powers of each base. So we would have 3 squared times 7 times 5. 3 squared times 7 times 5. 9 times 3 is 63. 63 to the 5th. Or sorry, it's not 63 to the 5th. That would be a huge number. It's 315. We'll do another example like that, but that's just what you do. This right here is going to be something for you to remember. We'll get through it, though. The upside-down division for 40 and 56. I'm going to take a number that goes out of it that's prime. This is one where you're going to want to keep it prime. Okay, we're going to keep it prime because we started doing that when we did our prime factorization, or when we did our listing of the primes. So we're going to just go 2. It's going to be 20. This is going to be 27. No, 28. Nope. Yes. T. T. All right, I got primes. Now here's the difference of GCF and LCM. GCF, we only took the left side. For LCM, what we're going to do is we're going to multiply everything of the top and on the left. Multiply everything on the top and everything on the left together. So we're going to have 2 times 2 times 2 times 5 times 7. Four times 7 is 28, so it's 280. Yes, sir? It doesn't always work whenever there's 3 numbers. Let me see. Let me show you a trick before we do that, okay? Here's a way to remember which of these, which side you do the LCM. Here's a way to remember on the upside down division what we do. Okay, that's the way you remember if you go just on the side or you just to go on the top. Do you take just the left side? I can't remember which one is it, GCF or LCM, that I just take the left side of the upside down division. Remember, like this, it makes an L for LCM.
I thought you were drawing a doorknob. I did too. Yeah. I was like, doorknob. Yeah, see? I thought it was a doorknob. Look, Johnny. No, it's McDonald's. That's the chimney.
I'm glad you guys are focused on a way to make sure you don't forget that.
I swear by doorknob.
Okay. Oh, the ones that doesn't work for, it's what was it? Yeah. For example, like this. Whenever they all have a common factor like this, this would be 7 times 12, which is 84. No, that doesn't work either. What is it? I'm trying to remember the exact. You know what? I'm going to get back to you on that, which one it doesn't count for. It might even be today, but off the top of my head, I can't remember. I meant to write that one down when it doesn't work. I would need a right click with this. And in order to right click with this, you have to go for a while. It's quicker just to walk over to my desk, you know. All right. Did you know that when you find the least common denominator of two or more fractions, you're really finding the least common multiple? I know. Education that doesn't stop. That'd be sad. Then your brains would just sit there and melt. You have the education of a 7th grader your whole life. Rewrite 10 and 16 using their least common denominator. So what we're going to do is does it tell us which one to do? Which one do we want to use? Which method to find the LCM?
Upside down division.
Ding, ding, ding. I trust that you guys know your multiplication facts good enough that you can do that. Especially when it's 10. Right? So now it asks us, whenever you multiply the denominator by, you must multiply the numerator by. So it says here, this is our new denominator. Does everybody have that list? So we have to say, what did we do to the 10 in the denominator to get to 80? Yes. We multiplied it by 8. So I'm going to put an 8 here. And it says that I have to do the same to the bottom and the top. That's the multiplicative property of equality. Multiplication property of equality. Then we have to multiply top by bottom, and that's the 5, 6, 7, 8 way that I remember that one ever since I was little. Did I tell you about my 5, 6, 7, 8 thing?
I love that one.
When I always had trouble remembering which one? I remember that it's 7 times 8 is always 5, 6, 7, 8, like that.
That's how I think my mom told me. I just know that 7 times 8 is 56. Oh, I just remember 5.
Good. Good. Yep.
I know 7, 8, 9.
And it's the same thing over here. So we have the least common denominator is 80. Five. Yep. Yep, you're right. I doubled one without taking half the other. Okay, good. Moving along. We are not going to talk about someone who's not here right now for good or bad. If it's going to be one way, it's going to be for good. Like we miss somebody, blah, blah, blah. Oh, it's not the same without them, blah, blah, blah. Positive. Not finding least common multiple with 3 terms with the upside down method. So we can do it with 3 terms. Upside down method, we're going to take a 4 out of here. No, we're not. Yeah, we are. No, we're not. I like to keep them prime. That way you don't get confused when you're finding prime factorization if you want to use that. Yeah. So now we have to multiply the L, the shape of the L. So I have 2 times 2 times 3 times 4 times 6. So it's going to be 4 times 12 times 6, which is going to be 24 times 12. 24 times 10 is 240 plus 48. Yes, sir. 288.
What is, you have 3 numbers and 2 numbers, and there's not a number that will go into.
Then you have to multiply that big of a number. I think you're trying to say if they don't share a common factor, then you are done. There is an LCM. You have to multiply them all together if they have no common factors. The what?
Oh, so you multiply the 2 or 3 numbers.
Mm-hmm. If they have no common factors.
So originally we could just multiply 12, 16, 24 to get our answer.
That won't be the least common multiple if you did that.
So why would it be the least common multiple if you didn't have anything to go in?
Because they don't share any common factors. That's why. Yep. All right. Yeah.
Why would you have to do 2 times 2 when you could have done 4?
I reiterate, I want to keep them prime on the outside so you don't get confusion if you choose that method to do your prime factorization that's on the test. Yeah, you're going to have a little bit from every section. Yes?
You could do like a L like that, and then the work inside the C, and then put your answer in there.
Interesting. Yeah. Yeah.
Why wouldn't it work?
Why wouldn't what work?
Okay, so it works with no factors, but it doesn't work with factors. Okay, just multiply 12, 16, and 24. I don't think that's going to come out to be 200. It's going to be like 10,000 something. Well, if the calculators go on.
Okay. I think I know how to answer your question. Yes. Here we go. 12 times 16 times 24. That is a common multiple of 12, 16, and 24. But it is not the least common multiple. I'm really glad you're focusing on the answer instead of a typo. Okay, so now this time that you're tuned in, listen. That is a common multiple.
Oh, but it's not the least.
But it's not the lowest number or the least. Good. Glad we're done with that. Listing multiples. I'm going to use the big number first. I got 30. I got 45. Ding, 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 ding. I know my math facts, so I know that I am done. I said, I know my math facts, so I know my math facts, so I know I am done. Finding the prime factorization, finding the least common multiple by prime factorization. I'm going to pull out this t right here. It's going to sit over there until the end. The y's going to go over here, and I got 2 times 4. And I got 2 times 2. And I got 2 times 5. So I'm going to go ahead and list these guys out. 2 times 2 times 2 times t. 2 times 5 times y. What? That's horrible. And I got 2 cubed times t. 2 times 5 times y. So that's exponential form. 1, 1, 1, 1. So now I have to take the base with the highest prime. Taking the base with the highest prime and multiplying those. Or, sorry, highest exponent. Yeah. Did I put too many 2's in there? Huh. Oh, there it is. Got it. So I do 2/3 times 5 to the first times y to the first times t to the first. So that's 8 times 5 yt, 40 yt, or ty. Usually it's in alphabetical order.
Wouldn't it be 2 to the 4th because there's another 2 at the bottom?
No, because the instructions on the other side of the page tell you to only multiply the bases with the highest exponents. Yes?
It's like a variable. You even do the list method.
Yes. You could do the list method. It would be, for example, the 45. Yeah, because you'd have t, like for this one here, the list method would be 45 n to the 5th, 90 n to the 5th, that sort of thing, because that just keeps going n times n times n times n. Using upside down division, I'm just going to go like that. And I'm going to take
15.
Okay, fine. We'll take 15.
Yay.
2, q, 3, n to the 5th. We're done. Yeah.
I have a question about the prime factorization.
Okay.
So you only take the largest base?
So you only take the largest base, he says. Let's find out.
Yes.
Look at that. You shouldn't have to. But yeah. So we have 15 times 2 times 3 times n to the, or 2q times n to the 15th. So that would be, I'll work this out just so you no confusion. So you have 30 times q, or 30q. Come here. Thank you. 30q times 3n to the 5th. So that comes up to be 90q n to the 5th. $90. Yep. Thank you. Yes, sir. In addition and subtraction, you can not combine like terms. But when you multiply, you are pouring them all into the same bucket rather than. Yeah, dividing would be just like as long as you had, it would just create a fraction. It would create a fraction. Yep. Combining like terms doesn't work with addition. Combining unlike terms does not work with addition and subtraction. Yes, ma'am. Okay, to go back in time by 2 minutes, to highlight again what we already highlighted. Let's do it a different color for the third time. Multiply the largest powers of each base. Okay? So if one of them had x to the fifth and the other one had x squared, the x squared is forgotten. Okay, it's like you go y. You go y now. Go take a nap. Let's see. So the base is here. Remember, that's a base. Remember that from our notes? Yes. All right, let's. Okay, so we don't need to do number 8. I meant to. Yeah, we don't need to do that because you can get that. So now with this one here, finding the least common denominator. And it's going to be 8m and 24k. 8m, 24k. I'm just choosing to do 3. No. I'm just choosing to do 2. No. 6k. How much time we got? We have literally 2 minutes. Not enough time. 2 times 2 times 2m times 6k, which is 8m times 6k, which becomes 48, okay? Your homework, page 203. 18 through 50. What? Yep. It seems just like a lot right now.